All right, welcome back. So today we are going to be solving what are called compound inequalities. So what compound inequalities are, the word compound means to join. So we're going to be having two inequalities together written as one statement. Now we have two different types of compound inequalities. We have what is called an and compound inequality, and we have what's called an or compound inequality. Those are two separate types of inequalities. And pretty much what it's saying is that we're going to have two simultaneous inequalities that are going to meet up eventually. So for example, -2 is less than x, which is less than 5. So we're going to try to find numbers that satisfy that equation that are between -2 and 5. Likewise, we're going to have what's called an or compound inequality, which is when we have two simultaneous inequalities that produce pretty much opposite answers. So we can't have a number that's less than -2, but also greater than 5. There isn't a number that's less than -2 and at the same time greater than 5. So those are what are going to be called our or compound inequalities. And we're going to be going through examples on an and inequality as well as an or inequality. But pretty much what it means is that we have simultaneous comparisons and we're seeing, hey, are these going to overlap or are these going to be going in opposite directions because it can't happen at the exact same time? So without further ado, let's go through an example of an and inequality. So when it comes to an and compound inequality, we have the word and because it has the solutions that those two inequalities will be satisfied at the exact same time. So going back to what I was verbally saying in our introduction, if we had a number that's greater than -2 but less than 5, well, that can happen. 0 is greater than -2. It's also less than 5. So that could be one solution to that compound inequality because it happens at the exact same time and it does satisfy both of those inequalities. So let's say we have 2 is less than x plus 3, which is less than or equal to 5. So we need to figure out what solutions or what values of x satisfy this compound inequality. Well, again, a compound inequality means that there are two inequalities. Oh, it's blue now. Oh no. Technical issues. There we go. We are back to gray. So we have 2 is less than x plus 3, which is less than or equal to 5. We technically have two inequalities here. We have 2 is less than x plus 3, and we also have x plus 3 is less than or equal to 5. So since we have these two inequalities, we are going to solve them separately. We have 2 is less than x plus 3, and x plus 3 is less than or equal to 5. All we did was break it up from one long compound inequality to two separate individual inequalities. And to solve this, we want to get our x all by itself. Over on the left-hand side is x plus 3, so we're going to have to subtract 3. Well, on the other inequality to our right, it's the exact same step. And that should make sense of it being the exact same step because it was what was in the middle to start out with. Well, we're going to subtract 3 on both sides, or sometimes we call it add -3. I personally like to say subtract 3, but hey, that's just me. So we get -1 is less than x. We also have x is less than or equal to 2. But we're not quite done yet. We want to flip that inequality. That way we have x is greater than -1. And we also have x is less than or equal to 2. When it comes to graphing these, at first we're going to want to graph them individually. So we're going to graph x is greater than or equal to -1. It's an open circle at -1, and we're shading to the right-hand side. We're then going to want to graph x is less than or equal to 2. It's a filled-in circle at 2 because we can include it, and we're shading to the left. But if you notice, these number lines are strategically placed. They all correspond to each other, and you're seeing that starting at -1, we're shading to the right, and starting at 2, we're shading to the left. Well, we're going to have overlapping regions with it because we're looking for answers that satisfy at the exact same time. So we're going to use an open circle on -1, a closed circle on 2, and as we can see, it overlapped from -1 to +2. Because it's an and, it happens at the same time, we're going to shade what would be overlapping. Awesome. With that in mind, please work on problems 1 through 5 on the note sheet and resume when you are ready to move on. All right, if you listen to my voice, that means you worked on problems 1 through 5 on the note sheet and you're ready to move on and talk about an OR example. So with an OR example, we're talking about something that's going to happen, but not at the exact same time. So compound inequalities using the word OR require you to find solutions that satisfy either inequality. In this setup, we're going to be looking for answers that happen in one or the other. Going back to the example that I was speaking about verbally, where we had a number less than -2 and also a number that's greater than 5, that doesn't exist. So we would have an OR compound inequality. It's going to be a number less than -2 or a number greater than 5. But let's go through an example. Let's say we have 4x is greater than 12 or 3x is less than or equal to -15. What we're saying here is that there isn't going to be a solution for both of these at the exact same time that happens simultaneously and overlapped. It's either going to be going to the left or it's going to be going to the right. There will be no overlapping. So since there are two inequalities, we're going to separate them. So we have 4x is greater than 12 and 3x is less than or equal to -15. We're going to solve these inequalities just like we normally would, and I notice that they're both a one step. On the left-hand side, we're going to divide by 4. On the right-hand side, we're going to divide by 3. So we get x is greater than 3 or x is less than or equal to -5. So can we think about a number that is greater than 3 but also less than or equal to -5? I don't really think so. So this is why we have an OR, because it's not going to be happening at the exact same time. It's not possible to have that number that satisfies both of those inequalities at the same time. So we're going to graph them individually first, and then we're going to bring them together. We're going to graph x is greater than 3. We have an open circle at 3 because we cannot include 3, and we're shading to the right because it's all the values greater than 3. We can then graph x is less than or equal to -5. So we have a filled in circle at -5 because we can include it because it's an equal to. And we're shading to the left. We're saying, hey, all the numbers less than or equal to -5. And if you notice, our arrows are going in opposite directions. So we're going to combine them together into one final number line. We're going to say, hey, is all the numbers less than or equal to -5? That arrow is going to the left, and all numbers greater than 3, that's going to be going to the right. And there's no overlapping here because it isn't possible to have a number less than -5 and also greater than 3. That doesn't exist. So this is why we have an OR compound inequality, and we combined it onto one line. And with an OR, you should see that they are going to be going in the opposite directions. A good visual cue for this is if you think about an oar on a boat, you have two oars, and those oars are on the outside of the boat. So you use those oars to pull you through. So you should have those arrows going in opposite directions, just like if you were on a boat. All right, folks, great job with this. Please work on problems 6 through 10 on the guided note sheet provided. And please come in with any questions, and please jot down any questions that you have from this video. You're working hard, folks. I'm proud of you. Have a good one.